So we're going to go over units of solution concentration. There are lots of different ways to represent how much stuff you have in solution. So we'll see what some of those are. One is already familiar to us, molarity, which is moles of solute over volume of solution. So liters of solution, the total volume that you have there. And that gets units of moles per liter. And we usually symbolize that with like a capital M, and I tend to underline it. That's just me. Molality is different. That is the moles of solute, again, over kilograms of solvent. Okay, so that's molality. And so again, we would represent that as moles per kilogram, and that gets symbolized with a little lowercase m. Mole fraction is another one. And that is moles of whatever it is we're interested in. We'll call it the solute for now, versus over the total number of moles present. Okay, so that means solute plus solvent. And that is a unitless number because it's moles divided by moles, and that gets the symbol of chi. Mole percentage is a pretty simple one. So again, that is moles of solute or whatever it is we're interested in over the total moles times 100. Okay, and then that would just be a percentage. Mass percentage is the same thing. It's the mass of the solute over the total mass, which would be solute and solvent, times 100, and again, that would be a percentage. Parts per million is one that we're kind of interested in. Typically, this would be like the mass of the solute over the mass of the solution, so the total mass. And then there'd be some multiplication factor. So for parts per million, it would be 10 to the 6th. Same sort of thing here for the parts per billion, except here it would be for 10 to the 9th. And this is represented as ppm and ppb. So those are all the different ways that we can represent concentration. But let's see how you might actually see this in a problem sort of setting. So here we go. We've got a problem here. We've got some sucrose, C12H2211, and that is in 0.332 kilograms of water. The final volume is 355 mils. So we want to figure out what the molarity, molality, mass percent, mole fraction, and mole percent is for this entire thing. So a first step is to convert to moles. So I've got 50.4 grams of sucrose, C12H22O11, and we're going to convert that to moles. So 1 mole of this stuff, the molecular mass of this, 342.23 grams. So the number of moles I have of this is 0.1473 moles of sucrose. And then I'm also told that I've got this many kilograms of water. I'm going to need the moles of that for other things. But so 1 kilogram of this stuff is 10 to the 3rd grams. And 1 mole of this stuff is roughly 18 grams. And when I do that, that comes out to 18.44 moles of water. Okay? And that is kind of enough to get me going. So molarity, I just need to know the moles of my solute and the volume of my solution. So molarity, A, this one is going to end up being 0.1473 over, this should be in liters, so 0.355 liters, and that comes out to 0.415 molar. The molality of it would be, again, my moles, 0.1473 moles over the mass of this, so 0.332 kilograms. That's my molality, and that would come out to 0.444 molal, so we put a little m after that. The next one that I'm looking for is mass percent. So I've got 50.4 grams of this stuff divided by, let's see, what do I have here? 332 grams, it's that many kilograms plus 50.4, so that's what the whole thing ends up being. Just throw that into the calculator here, so 50.4 divided by the sum of 332 and 50.4. And then that gets multiplied by 100, so that comes out to 13.2%, and that's the mass percent. And then if I want to get the mole fraction, I've got this many moles of my solute and this many total moles, so that's on bottom, and that will end up coming out to be 0.00792. And then if I want this in percentage, my mole percent, it's really just that number times 100, so 0.792%. And I'll just box all these so that they're easy to find. And those are the answers that we come to. And we really needed these two pieces of information plus what was given in the problem. So I hope that helps. Again, going between different units of concentration is not that hard, but it is something you'll be expected to do on a quiz or a test. So good luck.